Elementary Science Class 7. Winds. Air exerts pressure. Did you know that air exerts pressure all around us?
No, I didn't know that. How can we see this pressure in action?
Let's try an experiment. We'll need a tin can with a lid and some water.
Okay, let's do it.
First, we'll fill the can about halfway with water and heat it over a candle flame until the water boils.
And then what happens?
After a few minutes, we'll blow out the candle and quickly put the lid on the can.
What will happen then?
As the water cools, the steam inside the can will condense, reducing the air pressure inside. The higher outside air pressure will then cause the can to get distorted.
Wow, that's amazing. I can see how the air pressure is affecting the shape of the can.
Exactly. Air pressure is also responsible for things like wind, kites, and the way a bicycle tube keeps its shape. High-speed winds are accompanied by reduced air pressure. Did you know that high-speed winds are accompanied by reduced air pressure?
Really? I didn't know that. Can you explain more?
Absolutely. Let's try an activity to demonstrate this. Take this piece of paper and crumple it into a small ball. Now, hold this empty bottle on its side and place the paper ball just inside the mouth. Try to blow on the ball to force it into the bottle.
It's really difficult to blow the paper ball into the bottle. Why is that?
The reason is that when you blow on the paper ball, the airspeed near the bottle's mouth increases, which decreases the air pressure there. The higher air pressure inside the bottle then pushes the paper ball back out.
Wow, that's really interesting. Can you give me another example of how high-speed winds and reduced air pressure are related?
Sure, let's try another activity. Take these two balloons filled with a little water and hang them on a stick, about 8 to 10 centimeters apart. Now, try blowing in the space between the balloons. The balloons will move towards each other. This is because the increased airspeed between the balloons reduces the air pressure there, and the higher pressure outside the balloons pushes them together. Air expands on heating. Alright, let's try an experiment to understand how air expands when heated.
Okay, what do we need to do?
First, we'll take a boiling tube and stretch a balloon tightly over the neck. Then, we'll pour some hot water in a beaker and place the tube with the balloon in the hot water.
And what will happen?
Observe what happens to the shape of the balloon. You'll see it start to inflate as the air inside the tube expands due to the heat.
Wow, that's amazing. So the air is expanding when it's heated.
Exactly. Now, let's take the tube out and let it cool down. Then, we'll place it in some ice-cold water and see what happens.
Okay, I'm curious to see how the balloon will react to the cold water.
Great, now you're getting the idea. As the air inside the tube cools down, it contracts, and the balloon will deflate.
I see, so the air expands when heated and contracts when cooled. This is really interesting.
Absolutely. This experiment demonstrates the fundamental principle that air expands on heating and contracts on cooling. Wind currents are generated due to uneven heating on the Earth. Winds are due to the uneven heating of the Earth's surface. Regions near the equator receive maximum heat from the sun, causing the air to warm up and rise.
I see. And this creates a difference in air pressure, leading to the wind currents.
Exactly. The cooler air from the regions on either side of the equator, between 0 to 30 degrees latitude, rushes in to fill the void left by the rising warm air.
Interesting. So, it's not just the equator pole difference, but also the uneven heating of land and water that contributes to wind currents.
Yes, that's right. In the summer, the land warms up faster than the water, causing the air over the land to rise and the cooler air from the ocean to move in. This creates the monsoon winds.
Wow, I didn't realize how complex the factors are that generate these wind patterns. It's fascinating how nature creates these systems.
Absolutely. And the rotation of the Earth also plays a role in changing the direction of the winds. It's a delicate balance that keeps our planet's weather systems in check.